Hello everyone, I am Karthik, Assistant Professor of Mathematics, SNS College of Engineering. In this lecture video, I will explain about Green's theorem. Introduction to Green's theorem. Green's theorem is a fundamental result in vector calculus that is a relationship between a line integral around a simple closed curve and a double integral over the region. Let C be a positively oriented simple closed curve in a plane. D be the region bounded by C. If P of x, y and Q of x, y have continuous first partial derivatives on an open region that contains D, then integral P dx plus Q dy equal to double integral dou Q by dou x minus dou P by dou y dx dy, where P dx plus Q dy is the line integral and dou Q by dou x minus dou P by dou y is the curl of the vector field PQ. Statements of Green's theorem. Green's theorem relates a line integral around a closed curve to a double integral over the region enclosed by the curve. The formula is integral P dx plus Q dy equal to double integral d dou Q by dou x minus dou P by dou y into dx dy. Understanding the divergence and curl. Understanding the concepts of divergence and curl is crucial in vector calculus. Divergence. The divergence of a vector field measures the tendency of the vector field to either convergent or divergence away from a point. In mathematically, a vector field f of x, y, z equal to f suffix x, f suffix y, f suffix z. Then the divergence of del dot f equal to dou fx by dou x plus dou fy by dou y plus dou fz by dou z. Curl. The curl of a vector field measures the tendency of the vector field to rotate about a point. Mathematically, for a vector field, f of x, y, z equal to fx, fy, fz. Then curl del cross f vector is given by del cross f equal to dou f1 by dou y minus dou fy by dou z into I vector plus dou fz by dou z minus dou fx by dou x into j vector plus dou fy by dou x minus dou fz by dou y into k vector. Applying Green's theorem in the plane. Applying Green's theorem in a plane involves the relationship established between a line integral around a closed curve and double integral over the region bounded by the curve. First, we have to verify the conditions. We should ensure that the vector field f of x, y equal to p of x, y and q of x, y. Choose the closed curve. Identify the parameterize a simple closed curve C that encloses the region of interest. This curve can be explicitly, parametrically or implicitly depending on the problem. Compute the line integral. Integral p dx plus q dy of the vector field f around the closed curve C. This involves integrating the components p and q of f along the curve. Examples and applications of Green's theorem. Area calculation. Green's theorem can be used to calculate the area of the region bounded by closed curve. For example, p of x, y and q of x, y be the line integral can be transformed into double integral. Work and circulation. In physics and engineering, Green's theorem can be applied to calculate work done by a force field along closed path or circulation of a fluid flow. Next one, potential theory. Green's theorem is instrumental in potential theory, particularly in solving Laplace equations and Poisson's equations. Flux calculation. Green's theorem can also be used to calculate the flux of a vector field across closed curve. Stokes theorem. Green's theorem is a special case of Stokes theorem which generalizes the relationship between line integrals and surface integrals. Comparison of Green's theorem with other theorems of vector calculus. First, a comparison with Stokes' theorem. Green's theorem is a special case of Stokes' theorem in two dimensions. Stokes' theorem generalizes Green's theorem to three dimensions by relating a line integral around a closed curve. Comparison between divergence theorem. The divergence theorem relates a surface integral of a vector field over a closed surface to a volume of integral and divergence of the same vector field. Fundamental theorem of calculus. The fundamental theorem of calculus relates differentiation and integration for single variable functions. In summary, Green's theorem is a specific case of Stokes' theorem in two dimensions. Then it relating line integrals around closed curves to double integrals. Thank you.